coming back for our second. Today we're gonna go through series. We've got quite a good lesson today. We're gonna go through series. So series is what you guys learned today, picking up from what we did last week. So if you're not here, just a quick refresher. Last week we went through sequences, which you guys did in grade 11. We went through arithmetic sequences, geometric sequences, quadratic sequences. We did a few examples of each, and then we worked through the examples together. So the format is going to be the same today. We're going to go through the different types of series, talk about them, the different components, their characteristics, and then do a few examples. With each example, the examples today are a little bit more in depth. So I will give you time to do the example, and then after some time, we'll work through the example together. If you have a question, as always, guys, just put it in the comments, just ask in the chat, or you can raise your hand and ask me the question on the mic. And then, yeah, we work through the lesson. So let's get started, guys. Let me share my screen. Share. Okay. So this is today's agenda series revision. Okay. So what is a series, guys? A series occurs when we sum over the terms in a sequence. So last week we were just dealing with sequences. So sequences have terms, and these terms, nothing's really happening to these terms. It's just one after the other. Now, series is introduced when we start adding or subtracting over these terms within a sequence. So, for example, I give example here, a normal sequence would be something like 2, and then 4, 6, 8, and 10. Well, the series of that sequence would add all the terms. So we get 2 plus 4 plus 6 plus 8 plus 10. And what this enables us to put a value on a sequence. So, for example, the value of the sequence is now 30, and this is the value of all the terms added up. So when we're talking about series, guys, we get two different types of series. The first type of series we get is arithmetic series, and we know now that anything arithmetic when we're dealing with sequences or series occurs when we have um, a bunch of terms and we have constant difference between the terms. So here is when we add the terms in an arithmetic sequence, but we add a constant difference. So the example I gave here is 5, 8, 11, and 14. And the differences between these terms, I'm adding a constant 3 each time. Okay. So how you would go about deriving this formula, how they derive the general formula for sequences is obviously the first value is A. And the second term is A plus whatever difference I have, D. My third term is A plus 2D and A plus 3D, so on and so forth. The only difference that is changing here, as you can see, is my D, but I'm adding each time over my terms. Okay, let me go back. So the general term that you should be familiar with when it comes to arithmetic series is Sn is equal to n over 2 times open brackets 2a plus n minus 1 times d, where n is the number of terms, a is the value of the first term, and d is a constant difference between terms. So this is the nice thing about us having touched on sequences last week, is that most of the stuff is just the same. It's just the principle of what we're doing is changing. So n represents the same thing that it did in sequences. A as well as D, they all represent the same thing, even when we get to geometric in a few minutes. And then we denote a series by Sn instead of Tn. So if it's Tn, we know we're working with a sequence, the general term of a sequence, and Sn is the general term of a series. And this formula over here enables us to derive what the value of the series is for a given n number of terms. Okay, let me just check. Am I going to be including? Yes, yes. So towards the end, also the question was, are you going to be including the complex questions towards the end of the live? Yes, guys. I'm going to include one or two kind of harder exam-like questions towards the end of our question section, but we'll get through that. So we'll start with questions that are a little bit easier, and then some that are like medium level, and then ones that are more complex. So I will get to that towards the end. So yeah, just stay in tune, guys. Okay, let's continue. Okay, now geometric series occurs when we sum over the terms in a geometric sequence. But now we know that a geometric sequence, the difference between the terms in a geometric sequence is some constant ratio r. So the general term for a geometric series can be given as, oh, sorry, this is supposed to be Sn, not Tn. Let me change this quickly. Tn. Okay, this is supposed to be Sn. Okay. Yes, so the general term for geometric series is given as A, open brackets, r to the power of n minus 1 over r minus 1, or you could write it as A, y minus r to the power of n over 1 minus r. Remember, guys, this small little arrow here on my laptop, it just simplifies, it just means a power. So whenever you see this arrow, it just means to the power of. Okay, so you can write a geometric series either one of two ways. You can use the first formula over here or the second formula. You will get to the same answer. Note, and this is important, okay, r cannot equal 1, because what happens when r equals 1, our denominator will equal 0, and our series will then be undefined. Okay, so these formulas work for an r value that is either less or greater than 1, but not equal to 1. Okay, so those are our two series that we're going to work with, arithmetic and geometric series. And as I said, n is the number of terms in my series. Now, an important question to ask is, these two formulas that I've gone through right now, um, the arithmetic series, this one over here, and the geometric series, this one over here, these apply to a finite number of terms. What I mean by that is that n is some finite number. N can be 1, n can be 2, n can be 10, but n is an actual number. It stops, this series stops somewhere. Now, what happens when this series continues to infinity? What happens when, for example, in this example over here, it doesn't end at 10, but it kept on going 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, all the way to infinity? How do we work out the value of a series that goes to infinity? Now, if we were to look at an arithmetic series, a sum to infinity would simply be infinity plus minus infinity. Let me go back to that example again. If I take this example over here, and I add all these values all the way up to infinity, the value of that series is simply going to be infinity. If they were negative values, so minus 2, minus 4, minus 6, the series to infinity would simply be minus infinity. However, for a geometric series, it's different, a special kind of geometric series. For a geometric series that converges, and I'm going to get to that term now. For just 1 and 1, the sum to infinity can be given as a over 1 minus r. I'll repeat. For a geometric series with a ratio that is between minus 1 and 1, the sum to infinity can be given as a over 1 minus r. And this is what we call a geometric series that converges. Converges means it comes together to a particular number. To converge means to come together. So when we add the geometric series of this infinite number of terms where the ratio is between minus 1 and 1, we find that the numbers as we go to infinity, they keep on getting smaller and smaller and smaller and smaller, eventually until it's so small it's 0. And we can add those numbers until we get to the terms that are so small they equal to 0. And to find the value of that term or those terms, it is our series to infinity, which is a over 1 minus r. They love asking about geometric series to infinity. So just remember to memorize this formula, guys. A over 1 minus r. I think it's a nice formula to remember because it doesn't include as many components as the other two formulas. So we have three things that we've covered so far. We've covered an arithmetic series and its formula, the geometric series and its formula, and what happens when we have a geometric series to infinity and the formula that is given for a geometric series to infinity. Let me just quickly see if we have any questions. Okay, no. Okay, let's move on. Now, the one last thing I'd like to touch on before we go into some examples is sigma notation. Now, 9 times out of 10, the most complex questions that you will get when you're dealing with series is going to be some form of sigma notation question. Now, sigma notation is basically a way to simplify a sum of certain terms, a way to show that we're summing over certain terms. So this is a sigma here, the Greek symbol sigma. That's why it's called sigma notation. The top number over here is telling us what we're summing to. The bottom number is telling us where we're starting. So these are indexes. The bottom is telling us where we're starting. The top is telling us for what value we're ending. And then this is the function over here, or this is the actual series itself. Okay, so as I said, sigma notation is a very useful notation for the sum of a given number of terms of a sequence. The sigma symbol is used as the sum of. So you would read this, if you were to read this in English, it's the sum of all the terms from the first term, k equals 1, to the fifth term, k equals 5, for this sequence over here, a of k. And if I had to write that out, it would be a plus 2a plus 3a plus 4a plus 5a. 5 because it's ending at 5, and then a because it's ending at 1. And then obviously 1a is just a. Now, to work out the n value of a sigma notation, I like to use a little shortcut. N is the number of total terms in the sequence. All right. Now, to get the n value, you simply take the top number minus the bottom number plus 1. What do I mean by that? So if I wanted to work out, without writing out the terms themselves, if I wanted to work out how many terms I will have in this series over here, I will simply say the top number, which is 5, minus the bottom number, which is 1, plus 1. So 5 minus 1 plus 1 is 5. So there are 5 terms in this series. And I can double check by writing them out. A, 1, 2, 3, 4, 5, that is 5 terms. And the reason why we like that is a nice shortcut to use is because when you're solving questions and you want to know what your end value is, if the top number is 100 or a million, you don't want to write out a million series or a million terms before you figure out that there are a million terms. There's simply no time in the exam or in the test. So a nice little shortcut to work out your end value. You take the top minus the bottom, and then you add 1. Okay. So going forward, our A value, okay, this can be a little bit confusing, but just stay with me here. So A here, this capital A means the value of the first term. The value of the first term in this series is A, small letter A. D is our constant difference, and our constant difference is A again, because to get from A to 2A, 2A to 3A, 3A to 4A, and 4A to 5A, I'm simply adding A each time. So my constant difference is A. The value of my first term is also A. Okay, so I know that since I have a constant difference instead of a ratio, the kind of series that I'm working with is an arithmetic series. And we know that the formula for an arithmetic series is given as Sn is equal to n over 2, open brackets, 2a plus n minus 1 times our constant difference d. We have our n value, we have our a value, and we have our d value. So we can simply subs all those things in to give us that Sn, or S of 5, because there are 5 terms here, would be 5 over 2, open brackets, 2a plus 4 times a, and that will give me 15a. And you can double check by summing over these. You can double check this by adding up the terms and the terms that we wrote out. So if you had to add a plus 2a plus 3a plus 4a plus 5a, we should get the same answer as S of 5, which is 15. So that's a nice little example to wrap our minds around sigma notation and our geometric and arithmetic series. So I think we finally have the tools to do some practice examples. Okay. So as we previously did, what we're going to do, read through the questions. I will give you guys a few minutes to attempt the questions on your own. After you attempt the questions on your own, I will then go through the questions. We'll go through them together, and then you can see where you're going wrong. If there's something that you're not understanding, or you're not understanding why you're going wrong, or why we're not getting the same answer, you can put a comment. I'll keep on checking the comments consistently to see if anyone's asking anything, and then we can go through those questions. So the first question is consider the series 3 plus 6 plus 12, etc. A reads, write down the general term of the series. And B is, what is the value of the series when n is equal to 10? So guys, I'll give you 5 minutes to attempt those two questions. Okay, one more minute, guys. Okay, let's go through this question, guys. So we have a series here. They give us the first three terms, 3 plus 6 plus 12. And three terms is all we need to determine whether we're working with an arithmetic series or a geometric series. So let's quickly go through the answers. Okay, answers. So this is 1, 1A. Okay, so A asks for the general term of the above sequences that they gave us, right? Now, general term is not the same as the series. General term is asking me for the general pattern. How can I describe this pattern mathematically? This is not the same as Sn. When they're asking for general term, they're asking for Tn. Okay, what is the best way that we can describe the sequences that they've given us as a pattern? A pattern where we can substitute some n value or some r value, some d value, and get any answer that we may need. Okay, so the general term for this, a general term for okay, initially let's first actually establish what kind of series we're working with over here. So I have 3 and then 6 and then 12. 3 and 6 is The difference between 3 and 6 is 3, but the difference between 6 and 12 is 6. So there is no constant difference. So the only other option I have is that this is an arithmetic, this is a geometric series. There is some constant ratio. And to find this constant ratio, I simply take one term and I divide it by the term before. So to find this constant ratio, I can say 6 over 3, which is 2. And to check if it's correct, I will say 12 over 6, and that should give me the same answer, which is 2 as well. So we know that we're working with an arithmetic series, a geometric series, pardon, and this geometric series has a ratio of 2. So we know that for a geometric sequence, the general term can be given as Tn is equal to AR to the power of n minus 1. In this case, our A value is 3, our R value is 2, and thus the general term Tn can be given as 3 times 2, 3 times 2 to the power of n minus 1. This is the general term that describes the numbers or the sequences that we had been given. Now, the second question asks me, right, what is the value of this series when n is equal to 10? Now we bring in, there's a mention of a series, now we bring in our Sn formula. So they want to know, what is our n value? What is the value of our series when n is 10? In other words, if we have summing over 10 terms, so term 1 plus term 2 plus term 3 plus term 4 all the way to term n, if we added up all those terms, what would the value of our series be? Okay, so this is question 1b. Now, we know that the series, a geometric series, can be given as Sn is equal to A R to the power of n minus 1 over R minus 1. Okay, we have all we need to calculate Sn. We have our A value, which is equal to 3, yet again. We have our R value, which we worked out is equal to 2. And N value, which they've now told me is equal to 10. So Sn, or S of 10, you can use any notation that you like, is equal to 3, open brackets, 2 to the power of 10, my N value minus 1, over R minus 1, which is 2 minus 1, which is just 1. You quickly plug this into your calculator, and you should get that S of 10 is equal to 3069. Okay, so this is a nice example to show how they can interchange between sequences and series, which is why I began with sequences last week, because they 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 go alongside each other. They go hand in hand. You need to know your sequences, you need to know your series, because they won't just ask you questions directly related to series. You also need to understand your sequences and apply that knowledge to series as well to be able to get the full marks. So this is the answer for question 1a and b. Let's go to question 2. Now question 2 asks us to determine the sum of the series 19 plus 22 plus 25, which ends at the term 121. So that's the question. I'll repeat. Determine the sum of the series 19 plus 22 plus 25 plus some terms in the middle, and they end at plus 121. So there are two things that you need to do to answer this question, and I will give you guys 5 minutes to try and attempt this question, and then we'll go through it together. Okay, guys, I'll give you another 2 minutes. Okay, let's go through this question. So we're doing number 2 now. Determine the sum of the series, and they gave us a couple of terms starting at 19 and which end at 121. Now, as I said, there are two things that you need to do to answer this question. Okay. Now, if you try to answer this question by simply jumping into the series, you would have realized that there is something crucial that you're missing to answer this question, and that is the value of our n. We don't know how many terms are in the sequence because they don't give us every term in the sequence. Okay. So in order to establish what our n value is, we need to start with our general term. Okay. Now, let's determine whether we're working with an arithmetic or a geometric here. We have 3, we have 6, and then we have 12. No, pardon me. We have 19, we have 22, we have 25, ending at 121. Okay. Now, is it arithmetic? Let's see. 22 minus 19, that is 3. 25 minus 22, that is 3 as well. So we have a constant difference of 3, meaning we're working with an arithmetic series over here. But as I said, before we start with the series calculation, we need to determine what our n value is so we have all the components to calculate what the value of our series is. And to get the n value, we need our general term. Okay. Now we know that the general term of an arithmetic series can be given as Tn is equal to a plus n minus 1 times some constant difference d. Okay. Now, if I want to know how many terms are in my series, the last term will tell me how many terms they are. Okay. For example, if I just had a series with 3, 6, and 12, ignore everything that comes after that. It was just 3, 6, and 12. Okay. 12 is the last term, but 12 is also the third term, which tells me if 12 is when n is equal to 3, how many terms are there in total? There are 3 terms. So the same here, I want to work out what term is 121. And that number will then tell me how many terms there are in total because 121 is the last term. Okay. So I know the value of my term. I want the term number. In other words, I want my n value. Okay, so I know the value of my term Tn is 121. I know my a value. My a value is 19 plus n is what I want minus 1 times our constant difference, which I know is given as 3. So this is just quick algebra. Say 121 is equal to 19 plus 3n minus 3. Okay, you take over the constants to the side, you will get that your n value is equal to 35. So that is my n value. N is 35. 121 is the 35th term. So that means in my series in total, I have 35 terms. Now I have everything I need to calculate the value of this series, Sn. We know that Sn of a arithmetic series can be given as n over 2, open brackets, 2a plus n minus 1 times our constant difference d. And close those brackets. Let me use square brackets so it doesn't get confusing. Two sets of brackets there. We have everything we need. We know that n is 35, so s of 35 is equal to 35 over 2, open brackets, 2 times, what's the value of my first term? 19 plus 35 minus 1 times our constant difference of 3. You can quickly plug this into your calculator and you should get that s of 35 is equal to 2,450. 35 is equal to 2,450. So if that's the answer you got, guys, it's correct. Just be careful with these questions. Remember, there are two steps. I know if you try to jump into the second step immediately, you would have recognized after writing the formula that I can't calculate everything because I don't know what the value of my n is. So that's how you would have attempted this question, guys. Let's go on to the next question. We had question 3. If 2 plus 6 plus 18, etc., is equal to 728, determine the value of n. Now, if you look at question 2 and question 3, it's the same thing, just going backwards. So now they're giving me the value of my sum. They're giving me the value of my Sn, and they want me to work out how many terms they are. Okay? So I will give you 3 minutes to try and attempt this. This should be nice and quick, guys, using the logic of the question that we just did. Same thing, just going backwards. Determine the value of n, given that 2 plus 6 plus 18 plus however many terms there are is equal to 728. Okay, guys, let's go through the question. We're on question 3 now. Did I specify which questions? 1A, 1B. Okay, let me just number the questions. Okay, this is number 2. Okay, let's go on to question 3. So they're asking us to determine the value of n given the information that they have given us already. Okay. N. Right. So let's analyze this question quickly, guys. I have 2 plus 6 plus 18 is equal to some Sn value of 728. Now, as always, the first thing we want to do is determine exactly what kind of series are we working with here. Are we working with geometric series? Are we working with a arithmetic series? Now, 6 minus 2, that'll give me 4. 18 minus 6, however, that'll give me 12. So I can't be working with arithmetic series because I don't have be a geometric series. Now 6 over 2, that is 3. 18 over 6, that is 3 as well. So I'm working with a geometric series with some constant ratio of r is equal to 3. I also know that my Sn value is equal to 728. So I know that the value of my Sn of a geometric series should be a times r to the power of n minus 1 over r minus 1. Okay, but I know that the value of my Sn, which they've given me, is 728, which is equal to a is the value of my first term. Have they given that to me? Yes, the value of my first term is 2. Okay, so value of my first term is 2, value of my r is 3. So I sub those things in. So 2, open brackets, 3 to the power of n, which I'm looking for, minus 1, over r minus 1, which is going to be 3 minus 1, which is just 2. Okay, and this becomes an algebra problem because I have one variable that's missing. I have my equation. I just want to work out what my n is. Okay, so I can take these 2's will cancel out. 2 over 2 will cancel out. I'll be left with 728 is equal to 3n, 3 to the power of n minus 1. I can take this 1 over the other side. That'll give me 729 is equal to 3 to the power of n. Now, I know that I'm not quite sure if everyone knows how to solve this using logarithms. I love using logarithms to solve this. A nice little shortcut formula that I can give you guys is log of my base is equal to log base answer is equal to n. And what I mean by that is that my base in this instance, whatever my n is, whatever my power that I'm looking for, if my power is my variable, it could be 729, 2 to the power of x, 5 to the power of I, whatever my power is, which is my variable. To work that out, I will simply put in my calculator, log of my base times my answer will give me that power. So in this case over here, base is my base is 3, okay, because it's 3 to the power of n. So if n is the power I'm looking for, the base of that power is 3. My answer, the other side of the equation, so let me write this out, base is equals to 3. My answer, which is the other side of the equation, is equal to 729. I simply plug that into my calculator, and it will give me that n is equal to 6. So you've got 6 here, guys. That is the correct answer. It's a good job. If you're not sure which function on the calculator I'm talking about, directly below your on button. So just below your on button, you will see a log with a small gray block that is colored in, and then an empty longer rectangle, which is empty. So it's a log button with a small gray square and then an empty or white rectangle. Okay, and in that order, you put in log, and then the next thing that comes into the colored square is base, and then the white rectangle is your answer, and that will give you your n value. If there is another way that they maybe taught you in school that um, you can use, maybe you can get it to its base, you can get 729 to its base factors if you want to. If there's any other way that they taught you in school, you can use that. But for me, I've always found that this is the quickest and easiest way to determine what the n value is when our variable or our n is a power. Okay, so that's how you answer question 3 over there. Let's go on to question 4. Now, question 4 is when things start to get a little exciting. We start introducing our sigma notation which, as I said in the beginning, they love to use, especially in the more complex questions. But we'll go through a more simple example to wrap our minds around it, and then we'll go from there. So this question is asking us to evaluate, pardon me, to evaluate the sigma notation over here. So I have a summation from n equals 4 to n equals 70 of 2n minus 4. So I'll repeat, I have a summation. I am summing over the terms n equals 4 all the way to n equals 70 of 2n minus 4. I'll give you guys 5 minutes to try work around this, think about it, maybe come up with an answer. And then, as always, we'll work through the question together. Let me quickly just number the questions that we've done here. So 2, that's 2, 3, and now we're busy on question 4. Okay, it is a little bit small. Okay, another 2 minutes, guys. Okay, let's go through the question, guys. Now we're doing number question 4. So they gave us a sigma notation here, and they've asked us to evaluate what the value of n is. Okay, so evaluating a sigma notation is basically just the same as evaluating a series. So they want us to work out what the sum of the sigma notation they've given here is. Remember, I said in the beginning that sigma notation is another way of saying the sum of some sequences or the sum of some terms that they have given us. Let's go through question 4. Okay, now whenever you're dealing with sigma notation questions, the first thing that you always want to do, okay, the first thing you always want to do is write out the first few terms. First three, first four. Okay, even first three is okay. Minimum three though. The reason why is that is the only way that we'll be able to determine what kind of series I'm working with. Is it a geometric series or it is a arithmetic series? So write out the first three terms and then we can kind of gauge what kind of term we're working with. What is our A value? What is our R value if we're working with a geometric series? What is our D value if we're working with an arithmetic series? So let's write out the first few terms. So it's 2n minus 4, n starting from n equals to 4 to n equals 17. Okay, so our first term will be 2n minus 4 plus our second term is when n is equal to 5. So 2, 5 minus 4. And then the third one minus 4 is 2. And n is equal to 6 minus 4. Sorry, this n here is supposed to be at 4 because they're telling me that we're starting at n is equal to 4. We can quickly simplify these to get that 2 times 4 minus 4. That'll give me 4 plus 6 plus 8 plus, we know that this continues all the way until n is equal to 17. So this does the same. Okay, now we have enough information to try wrap our minds around the question. So we know that for whatever we're working with, our A value is equal to 4. That is the value of our first term. Okay, now let's check, are we working with an arithmetic or we're working with a geometric? 6 minus 4 is equal to 2. 8 minus 6 is equal to 2. Immediately, I notice a pattern that there is a constant difference of 2. So each time I am adding 2 to the next term to get the next term. That means we're working with an arithmetic series. We have a constant difference d of 2. Okay, now as I said, to work out what my n value is, To work out how many terms I have in the sigma notation I'm given, it's going to be top minus bottom plus 1. That's the same as n is equal to 70 minus 4 plus 1. And that should give you that n is equal to 67. Right? That's n is equal to 67. Great. Now we have everything we need to evaluate the sigma notation that we've been given. So we know that this is an arithmetic series. I write out my formula. Remember to always write out your formula, guys. You do get marks for it. N over 2, 2a plus n minus 1 times our constant difference of d. Okay. Given what we have, we can simply substitute it in. So we know that n is 67. So s of 67 is equal to 67 over 2, open brackets, 2 times 4, plus our n is 67, 67 minus 1 times our constant difference of 2. You can quickly plug that into your calculator, and you should get that the summation is equal to 4,690. So S of 67 is equal to 4,690. So that is the answer for question 4. Okay. And the way in which I approached answering the sigma notation is the general way you want to attack sigma notation questions. First thing, always begin by writing out the first 3 or 4 terms so that you can pick up a pattern. You can notice a pattern, you can determine what kind of series you're working with, what you're missing, what you have. You can determine your A value, your R value, or your D value, depending on what kind of series you're working with. So that is always a first step that I use when I am working with a sigma notation question. Let's go on to question 5. Now, question 5 asks us to consider the following series: ax squared plus 4x cubed plus 2x4. Now, it asks us to determine the nth term of the series A. B asks us for what values of x will the series converge. And C asks us to calculate the sum to infinity if x is given as 3 over 2. So this is more of a more complex question than the ones that we've been doing, but you should be able to apply the same principles that we've been using all along to answer this question. So I'll give you a little over maybe 6 or 7 minutes to try and answer this question. We'll do both A, B, and C, and then we'll go through each of them in depth. Remember, guys, these arrows over here just mean a power. So this is ax squared plus 4x cubed plus 2x to the power of 4. Okay, 2 more minutes, guys. Okay, let's go through this question. So there are three subsets of question 5. Okay, so the first question asks us to derive the general term. Now, the general term is the general pattern, which is our Tn. Okay, now let's first determine what kind of pattern or what kind of series we're working with here. We have ax squared plus 4x cubed plus 2x to the power of 4. The fact that the powers of the x's are changing should tell you that that is enough to know that we're not working with an arithmetic pattern, because um, there's no constant difference that will change the powers of a given base. Okay, so we must be working with a geometric series. And to work out what our r value is, we'll take 4x cubed and put it over 8x squared, and we should get that that should give us 1 over 2x. Okay, and to make sure, we'll take 2x to the power of 4 and divide it by 4x to the power of 3, and that will give us 1 over 2 to the power of x again. So our r value is 1 over 2 times x, or just x over 2. Okay, so my a is equal to 8x cubed, which they gave me, cubed, and r is equal to x over 2. Okay, general term of a geometric sequence is equal to ar to the power n minus 1. And for the general term of this sequence that they've given us over here will be our a value, which is 8x to the power of 2. R value is x over 2, and all of this to the power of n minus 1. Okay, so that is our general term. It's 8x cubed, 8x squared, pardon me, 8x squared times x over 2 to the power of n minus 1. That is our general term Tn. Let's look at part B. So this is 5a. So 5b. Now 5b is asking me, for what values of x will the series converge? What values of x will the series converge? Now remember, I said in the beginning that converges means to come together, and that we had a special characteristic of our geometric series is that it will converge for certain values of r. Okay, we know that geometric series will only converge when r is between -1 r and 1. Okay, so when my ratio is between -1 and 1, my series to infinity will converge. it will converge to some number that we can calculate. We have our R value, we have our inequality, we simply substitute our R value into R to get our inequality, to get the values of X that the series will converge. So substituting, we get -1, our R value is X over 2, X over 2, and then 1. I know that when I'm working with an inequality, what I do on the left, I do on the right. So to get rid of the 2, I multiply both sides by 2, which will give me -2 x 2. And that is the answer. So our series that we've been given will converge when our x value is between -2 and 2. So if we have a sum to infinity of the series we've been given and we want to work out for what values will it converge, it will only converge when x is between -2 and 2. If x is less than -2, it'll go to infinity, to some infinity, and when x is greater than 2, it'll go to some infinity as well. It's only when x is between -2 and 2 that we get an actual value for which it will converge. Okay, let's go through 5c. Now 5c asks me to calculate the sum to infinity if x is then equal to 3 over 2. So instead of some variable x, they actually give me a number that I can plug into my x, which is 3 over 2, and they want us to work out the sum to infinity. Okay, now sum to infinity s of is equal to a over 1 minus r. Okay, this will then be equal to my a value. My a value is 8, but 8 times x squared. But they tell you that x is now 3 over 2. So if you plug into your calculator 8 times 3 over 2 squared, that will give me 18. So 18 is my numerator, which is my a value, over 1 minus r. Now my r value is x over 2, but they tell me that my x value is 3 over 2. So 1 minus 3 over 2 divided by 2 is equal to 1 over 4. Okay, so 1 over 4, 1 minus 3 over 4 will give me 1 over 4. So it's 18 over 1 over 4. And this will give me an answer of 72. So that is what my series converges to. When my x value is 3 over 2, it'll converge to 72. Say that this is equal to 72. Okay, so I'll quickly go through that one again. So what we did is we took the terms that they gave us. We give the terms that they gave us. So there's 8x squared plus 4x cubed plus 2x4. We determined what kind of pattern we were working with. We determined our a value and our r value. And from that, we were able to determine for what values it will converge. And then we'll calculate the sum to infinity, substituting what we know from x to 3 over 2. And that gave us that the sum to infinity for this given sequence is 72 when x is equal to 3 over 2. Okay, so the last question that we're going to do for today is question 6. Now, question 6, I did put an asterisk. It is a bit of a higher order question. So the question asks, if I have a sigma notation from p equals 0 to p equals k of 1 over 3p plus 1 over 6, which is then equal to 20 and 1/6, determine the value of k. I'll repeat. If I have a sigma notation from p equals 0 to p equals k of some term 1 over 3p plus 1 over 6, and that is equal to 20 and 1/6, what is the value of k? To what value am I summing over? Okay, I'll give you guys another 5 minutes to try and work this one out. Think about it. It does seem complicated at first, but if you break the question down to the components that we've gone over already, you should start to see a path or a light to the answer. Okay, so think about it carefully, try to break it down simply for you guys, and do one step at a time. Okay, let me just number the questions. 5A, determine the nth. A, 5B. This is 5C. Okay, guys, another minute. Okay, let's go through number 6. So 72. Okay, so we're doing question number 26 now. Sorry, number 6. Okay, now as I said, guys, whenever I see a sigma notation, the first thing I always want to do is write out the first few terms. That'll enable me to kind of wrap my head around what I'm working with, and then maybe make some assumptions that can enable me to answer the question. So let's maybe write out the first 3 or 4 terms of the sigma notation over here. Okay. So I know that the value of the first term will be 1 over 6 plus value of the second term is 1 over 3 plus 1 over 6. And the value of the third term will be 1 over 3 times 2 plus 1 over 6. Okay, now I can simplify these and it will give me 1 over 6 plus 1 over 2 plus 5 over 6. Okay, so this is the value of my first 3 terms. Okay, now this enables me to determine what kind of series I'm working with. So let's start by determining if I'm working with an arithmetic series. So I'll say 1 over 2 minus 1 over 6, and that is 1 over 3. I'll say 5 over 6 minus 1 over 2, and that is 1 over 3 again. So for each time, I'm adding a constant difference of 1 over 3. So I write that down. My difference is equal to 1 over 3. And I know that I'm working with an arithmetic series. Okay. I also know that the value of my A, which is my first term, is equal to 1 over 6. Right. Now, this is an arithmetic series that I'm working with, and they've told me what the value of this arithmetic series is. They've told me that the value of this arithmetic series is equal to 20 and 1/6. Okay, so I know that Sn, the formula for my arithmetic series, can be given as Sn is equal to n over 2, open brackets, 2a plus n minus 1 times our constant difference of d. Okay. Now I know that they've given me the value of my Sn. Sn is equal to 20 and 1/6. Now, a nice little way to convert this mixed fraction into a proper fraction is to multiply 20 by your denominator and then add your numerator. So whatever base you have, multiply it by your denominator and add your numerator. So 20 times 6 plus 1 will give me 121. So this, in improper fraction form, is 121 over 6. So I know that my Sn is 121 over 6. 121 over 6 is now equal to n over 2, open bracket, 2 times my A value is 1 over 6, as I've said, plus n minus 1 times my constant difference of 1 over 3. Okay. Now it's simply a matter of working out what my n value is. Okay. So I can simplify this. 121 over 3. I'll take the 2 over. So it is n over 2. I take the 2 over and multiply by 121 over 6, and that'll give me 121 over 3. 121 over 3 is then equal to n, open brackets, 2 times 1 over 6 is 1 over 3, plus 1 over 3n minus 1 over 3. The 1 over 3's will cancel, and I'll be left with 121 over 3 is equal to n, open bracket, 1 over 3n. So n, open bracket, 1 over 3n. Okay, quickly work that out. We can multiply those n's and I'll get 1 over 3n squared is equal to 121 over 3. Okay, goes to the next page. So 121 over 3. 121 over 3 will be equal to 1 over 3n squared. N to the power of 2. Okay, I divide 121 by 1 over 3, and that'll give me 121 is equal to n squared. 21 is equal to n squared. Okay, square root 121, and that'll give me n is equal to 11. Okay, the reason why it's positive 11, because you can't have a negative n value. So even though the root of 121 is plus minus 11, you cannot have a negative n value. You cannot have a negative number of terms. That doesn't make any sense. So n will always be positive. Okay, let me just write that on the side in color. N is always positive. Highlight that. So my n value I know is always positive. Now we get that n, the number of total terms in this series, this arithmetic series that they've given me is 11. However, they're asking me for k, not for n. But I know that my n value, I worked out as n is equal to top minus bottom plus 1. Bottom plus 1. N is equal to top minus bottom plus 1. However, I know that my top is my k value, which I'm looking for, minus my bottom. My bottom is the bottom that they've given me here is 0. So minus nothing plus 1. It'll simply be k minus 0 plus 1. But I have worked out what my n value is. It's 11. 11 is equal to k plus 1. I take over the 1 to the other side. It'll give me 10 is equal to k. Thus, k is equal to 10. So let's quickly backtrack on our steps and see everything that we did. The first thing that we did is write out the first 3 terms. We got that the first 3 terms was 1 over 6 plus 1 over 2 plus 5 over 6. Okay. From these first 3 terms, we were able to determine what our constant difference is. We determined that we're working with an arithmetic series. Thus, our constant difference was 1 over 3, and our a value, which is the value of our first term, was 1 over 6. We then wrote out the general formula for an arithmetic series, which is n over 2, open brackets, 2a plus n minus 1 times d. We wanted to work out n, the number of terms, so we subs in everything else that we had. They gave us our Sn, which we worked out as 121 over 6, which is equal to n over 2, 2 times our a value, which is 1 over 6, plus n minus 1 times our d value, our constant difference of 1 over 3. We simplified it to get that our n value is equal to 11. However, realize that n is not what we're looking for. N is not what the question is asking. The question is asking for my k value. But I know from before that to calculate my k value, or whatever is on top of my sigma sign, it will be k minus my bottom. N is equal to top minus bottom plus 1. N, my number of terms, is whatever's on top of my sigma minus whatever's on bottom of my sigma plus 1. So n was equal to k minus 0 plus 1. However, from everything that we've done so far, we'd already worked out what our n value is. Our n value was 11. 11 is then equal to k minus 0 is nothing, plus 1 is 11 is equal to k plus 1. We took over the 1 to the other side to get that our k value is equal to 10. So that is how you approach that question, guys. It is a multifaceted question. This would probably be around 4, 5, or maybe even 6 marks because there's a lot of steps that you need to take to get the value of your k. But that is how you do it. Notice how we follow whatever kind of question we're working with when we're dealing with sigma notation. We kind of follow the same general steps. We take the same steps, and that is how I'd like you guys to break down the question and attempt approach every question that is a sigma notation question. First step is always to write out the first few terms. The second step, from those terms, determine what kind of series you're working with. And from there onwards, you can then try to break down the question even further and get to the answer. Okay. That is it for today, guys. I will, as always, we do make sure that the notes are available to you guys. I know a lot of you are not here, but you're going to watch the YouTube video. Please watch the YouTube video that we're going to we're going to upload, guys. You can pause and rewind if you don't understand. Maybe rewind if I'm speaking too fast. You can pause even longer if the time that I gave you to do the questions is not long enough. You want to maybe do the whole question before you listen to the answer. So please watch the videos, guys. This is our series revision, all done. I don't know if anyone has any questions. I know there's one person watching. All good? Okay. Thank you. See you next week, Wednesday, guys. Thank you.
Cheers, cheers, guys.